Hi class, hope everybody's doing well. We're here today just north of Cedar City looking at some more rocks. If you look behind me, I want you to look at these rocks and see if they look familiar to you. Have you seen any rocks like these dark colored layers that you see behind me? Maybe you're thinking, yeah, of course I have. Those are lava rocks. If that's what you're thinking, yes, you're right. Those are lava rocks, which is actually the topic of today's mini lecture. We're going to discuss igneous rocks. So igneous rocks are rocks that are formed from cooled or hardened magma or lava. Lava is molten rock that has been extruded onto Earth's surface or erupted from volcanoes. And magma is molten rock that is beneath Earth's surface or below volcanoes. We actually happen to be sitting or standing right now on an extinct volcano that erupted about 1 million years ago. This is called a cinder cone volcano. And if you look just to my right, you can see some tailings where this cinder cone has actually been mined to produce materials for road base or for landscaping and things of that sort. Oh, hi class. How you doing there? Don't mind me, I'm just crawling out of this creepy hole. Apparently there's some weird things in the hills here north of Cedar City. Let's head down the hill and talk about igneous rock textures and compositions for a sec. So the two most common way that igneous rocks are described is through their texture or through their composition. When we discuss igneous rock texture, we are basically referring to the size of the crystals within that igneous rock. More coarse-grained or larger crystals means that rock cooled down slowly or came from magma. Smaller crystals or a finer grain texture means that rock cooled very quickly or came from lava. Composition is a description of the minerals that are within that rock or what that rock is composed of. And the terms that we use to describe composition is mafic for an igneous rock that's really rich in iron and magnesium, and felsic, which is a rock that is rich in silica. So if you look at this rock, or if you could look at this rock, you would notice that the crystals are really small. It's really fine-grained. So this rock came from lava. It cooled quickly on Earth's surface or above Earth's surface. The biggest clue that we have for composition is that it's really dark-colored. And what dark color typically means is that it has a mafic composition, so rich in iron and magnesium. Composition is really important when we think about the ways that volcanoes erupt. Not all volcanoes erupt the same way. Some create really large explosive eruptions, and others create small, wimpy, mellow eruptions. Volcanoes that are mafic in composition have a tendency to be more mellow. They have a tendency to have larger lava flows, and much less debris is shot into the air in these mafic eruptions. We refer to this as an effusive eruption style. So to summarize, this outcrop, it's dark in color, and it has really small crystals or a fine-grained texture. So what this means is that this outcrop formed from lava that erupted in an effusive eruption style. All right, so we have switched locations. We're now at Three Peaks Recreation Area. We are standing on another outcrop of igneous rock. But as you can see, this igneous rock looks drastically different from the rock we saw at the last stop. The most notable difference is the light color. That's because this rock has a different composition. It is felsic instead of mafic. It's more rich in silica and less rich in iron and magnesium than the dark rocks we saw at the last stop. The other difference you'll need to look more closely to see is the texture. This rock has a coarse grain texture, meaning the crystals are visible. This is because this rock is not lava rock. This rock formed from magma. It cooled very slowly beneath Earth's surface about 21 million years ago. And as it cooled, it gave the crystals more time to grow, allowing them to become larger, giving it the coarse grain texture. If mafic magma produces really wimpy, effusive volcanoes that extrude lava that slowly flows onto Earth's surface, what happens when a felsic volcano erupts? Well, of course, it's going to be explosive. It's going to be the opposite. And the reason for this is because of viscosity. Felsic magma and felsic lava is much more viscous than mafic magma and lava. And what this means is it resists flow. It can't flow as easily. And due to this, within a felsic magma chamber, the pressure is going to build a lot more because the magma, frankly, doesn't want to move. So the pressure builds and builds and builds. So when it finally does burst and reaches the surface, it extrudes a lot more explosively. And the debris shoots a lot higher into the air. It spreads out a lot farther, and it can devastate a much larger area than mafic volcanoes do. So some examples of this are Mount Vesuvius that destroyed Pompeii, or Mount St. Helens, which killed many people in the 1980s. These were explosive, much more felsic volcanoes. So to summarize, mafic means a composition that is rich in iron and magnesium, and it produces effusive volcanic eruption styles. Felsic is magma and lava that is rich in silica, and its volcanic eruption styles are much more explosive and devastating in nature.